To arrest the spread of COVID-19, the most commonly used masks are surgical face masks and N95 respirators. Surgical face masks, which are relatively inexpensive and available, are not deemed to be as effective. They also raise a concern about the tensile design, which applies non-uniform pressure on the face and may cause serious bruising over long periods of use. N95 respirators, though effective, are not readily available. In both these masks, the largest concern is the environmental implication. The disposal has become an environmental challenge. Although N95 can be decontaminated using hydrogen peroxide, this process is yet to be widely adopted in India and still limits it to 20 uses before disposal. While it is still recommended that N95 masks be used for health professionals, it may not be possible to provide the same for patients and symptomatic persons. Given the above, we are looking for technology to make efficient, cost-effective and biodegradable masks that can be disposed without environmental concerns. We are presenting an investigation of recycled paper molding, popularly seen in egg crate manufacturing, to make the masks. This technology has two distinct advantages. It would make large quantities of regulated quality masks available quickly and at a nominal cost per piece, on machinery that is widely available and scalable. The second one being that there will be no environmental concern regarding the disposal of these masks, as they can be easily biodegraded through aerobic processes. The other advantages of this design include: 1. The molded design provides a more ergonomic fit to the face, distributing the pressure uniformly. 2. The vacuum process can be modulated to vary the density and thickness of the molded pattern to comply with varying regulatory requirements. Example: N95 requires up to 300 nanometers or 0.3 micrometer particle size compliance. 3. The automated process already in place for manufacturing of molded fiber reduces human contact points, reducing the need for expensive cleanroom standards to be maintained in the process. 4. Experimental results indicated that the material is not only elastic plastic, but also that it has viscous or emplastic characteristics. 5. The use of hypoallergenic, non-irritant acrylic adhesive on the lining of the mask may help in proper sealing, preventing leakages and avoiding bruises caused by use of metal nose strip as in surgical masks. This adhesive is widely used in medical dermapore tapes. It is permeable and allows perspiration while maintaining water resistance. 6. The mask itself and the mounting accessories are investigated to improve the safety and convenience of the user experience. Some grey areas that need to be addressed and investigated further through expert advice are as follows. 1. The sterilization and neutralization of odors and other chemicals present in the raw material. 2. The compliance of filtration regulations versus the ease of breathing through the material. 3. The finishing process of the masks will need to be carried out in clean room standards to maintain sterility.